Hello everyone, welcome to our 24th meetup, 5 things that you must know about GPT-3. My name is Dovydas and I'm the president of the Artificial Intelligence Association of Lithuania. I'm also a machine learning team lead at Vinted, and I'm also a founder of Tribe of AI learning community. So let me tell you about the plan for today. Today we are going to first of all have our usual introduction, then we are going to have a presentation, 5 things that you must know about GPT-3, and finally we'll finish off with some networking. So let's start with the introduction. What do we have to know about Tribe of AI? And before we do Tribe of AI, actually, let's talk about the Artificial Intelligence Association of Lithuania. So as I just introduced, I am the president now, and I became the president just very recently, just last month. Together with the board members, we are working on building the vision for the Artificial Intelligence Association for the next year. We will actually have like a general all members meeting in a week. And the next season is going to, I really hope that the next season is going to be pretty great for the association. We are actually really trying our best to do a lot of great things as the association. And one of the things which I would like to suggest for you is I would like to invite you to become members of the association. So if you are interested in becoming a member, please fill this form. It's actually on our website, lithuania.ai. And I'll also post the link to the Tribe of AI platform. So if you're interested, like we do not guarantee that everybody is going to be accepted. We are doing like this vetting procedure so that only people who are actually learning or working with AI can become members. But if you are interested, please go ahead and fill out the form. So that said, let's continue to talking about the introduction to Tribe of AI. For those of you who are new here, Tribe of AI actually does 3 things. So first of all, we organize meetups, like for example, the one in which you are right now. So today is actually our 6th remote meetup. I really expected that this is going to be the last remote meetup this year. However, as we see the situation, the coronavirus is not improving. Therefore, we decided to go and make all the meetups in 2020 remote. So I hope that it saddens me a little bit that we have to do that. It was really amazing. Like the actual meetings were really cool, and I had so many very interesting conversations after these meetups. However, I believe that we have to learn and adapt and make the best out of the situation. At least the meetups are allowed to continue, and what's even better, more people can participate in these meetups when we don't have to travel and we don't have to do we can participate from anywhere. The other things that Tribe of AI do are bootcamp. So bootcamp is actually not active right now. It's finished. It finished in spring, and you're preparing for the next season. We estimated that it will start in September. However, looks like that it will most likely start at the very, very end of the year. Also, what we do is Tribe of AI Academy. So Tribe of AI Academy is still active. The idea is that you can learn AI with no prerequisites. That's was our goal from the beginning. The principles, we do not create content. That means that there are quite a few good resources on the internet which provide AI education for free. the really tricky part is to structure these tens. Maybe I would say we have about 30 different resources to structure all of them in the correct order and filter them out, filter these 30 good resources out of hundreds and hundreds and hundreds of not so good resources, which or like even blatantly incorrect ones or giving you wrong advice. So the content creation part, creating content is not as tricky as actually choosing the best content that's available for you. We are also very practical. That means if you really want to minimize the theoretical part of this, like academy, we aim on actual coding and actually hands-on learning. We also aim to maximize your success rate. That means we are trying to make the experience like good for you. So therefore, you are like you have good chances of finishing the academy. And in the end, we try to use agile and lean principles while like delivering the content and like organizing the whole academy. We structure the Tribe of AI Academy into 7 classes. So these classes range from like F class, which is for total beginners, and it teaches Python fundamentals, and the S class is for people who are like have advanced deep learning knowledge already, and most of them are actively working with AI, machine learning, deep learning at their works or at or they are building artificial intelligence projects as their hobbies. The structure of the academy is like so. We study for 8. We have a commitment of 8 hours per week. We meet every Saturday. We learn on our own and we sync during our like Saturday meetings. The main strengths is the feedback from the participants and how I see them is that we really try to embrace the social aspect. We really try to share all of our knowledge, collective knowledge, including people who have graduated from the class and like the knowledge of our mentors. And we try to bring up, we try to improve our like fellow Tribe of AI members. And finally, we want to make meaningful connections. So if you are interested in participating, there are 2 options how to do that. We have a paid option. So that's just if you want to support Tribe of AI, you can go ahead and choose the paid option. Or if you don't want to invest any money, you can still get everything for free. What you have to do is you have to prove your motivation by writing a motivational letter. You can find all of these like Tribe of AI new teams. We have quite a few teams like in the works. They are going to be announced really shortly, and like you can join them on our platform. So the 4th thing which Tribe of AI does is it has a platform. The platform is like there everybody like it's a little bit better than the alternatives such as Facebook groups or Slack channels. So this is actually a pretty expensive paid Mighty Networks platform. However, I believe that it suits our needs exactly right. And it is the place for all the important information, including all the content. By the way, all the content from Tribe of AI Academy is available for free right now. You don't have to do any motivational letters. You don't have to pay for anything. You can just go to our platform, sign up, and get everything right now. What you are like, so only if you want to join a team, that's the part where you fill the motivational letter or subscribe. So it's like all our resources are there, all our events are there. It's pretty much the hub, the central hub of whatever this community does. And it's open. You can go ahead to go to tribeofai.com and join up. So now the interesting part, presentation. 5 things that you must know about GPT-3. GPT-3 is the most, I want to say, the most important machine learning or AI development in 2020. I hope that it's really amazing, but I still have like a bit of hope that we might still see some amazing things. The year is only halfway done, so at least it's the most amazing thing in AI this year so far, probably in a while. So GPT-3 stands for General Purpose Transformer. It is a language model. Let's see our plan for today. So first of all, we are going to talk about what language models are. Then we are going to talk about what transformers are. Then we are going to talk about the inference of GPT-3, what is few-shot learning, and what does it mean and why is it important. We also are going to talk about the parameters, training data, fairness, and finally the performance of the model. So let's start with a quote from the CEO of OpenAI, Sam Altman. So he actually has this quote saying that GPT-3 hype is way too much, and thanks for the compliments, but says that the model has some weaknesses and it makes silly mistakes. That's certainly true. I don't. I'm the person who really hates when people start to interrupt like make personal make AI human like, but GPT-3 can sometimes like the performance of the model might give us an idea that the model has some reasoning capabilities which it doesn't. So let's first start what this thing is, how it works. So it is a language model, and the main mostly the main thing that GPT shows is that the language model performance scales as a power law of model size, dataset size, and the amount of computation. So what does it mean? It means that the language models, we have a lot of, like we thought that we have pretty big language models. Like recently, even like BERT felt quite a big model. Then we had a few bigger ones, not as widely used in more for like they felt like more for research projects. BERT was the one. BERT, Alberta, BERT, Roberta, Albert. These were the models which we actually used in like day-to-day work. However, GPT-3 is it's an even simpler model, however, much bigger. So the language models itself are very simple. They just predict the next word, as in GPT-3. The GPT-3 is not even bidirectional, just predicts the next word. Or they predict a few masked words. That's how BERT does that. They mask 50% of the words in like a piece of text, and then we try to predict these words based on the context. It is also a self-supervised learning problem, so we don't have to create any labels manually. We can use any text corpuses available, and we'll talk about the data what GPT-3 uses in the next slides. So what type of tasks do language models solve? First of all, we use language models for translation, probably the least need of explanation example. Summarization. So what this means is we provide a larger text corpus and we expect a shorter text corpus. Then we can predict my next word. So that's like, for example, how autocompletes were not autocompletes, but not autocompletes as in completing the word, but autocompletes as in Gmail, which predicts the next few words. Also, question answering. That's one of the, like, we don't see a lot of these because the state of the art is not too great. At least it wasn't too great until GPT-3. Now it's pretty amazing. So question answering, you can ask, give it a natural language question to the model, and the model provides an answer. Finally, named entity recognition. So that's the model just understands what like each token in the text, what does it stand for. Let's talk about the timeline of language models. First of all, we had these very simple feed-forward neural networks, such as word-to-vec. Actually, like most, guess the most important thing here is we had embeddings here. So word2vec and glove, they were super simple models which trained to give us embeddings of the words. They were very useful for like this initial natural language work. Then we had a bit of a breakthrough with recurrent neural networks. Most notable architectures are LSTM and GRU. They're quite popular. People like to argue which one is better, GRU or LSTMs. And finally, now we have like this third stage or first iteration language models, which everything is based on transformers. We might even say that transformers are doing what convolutions we're doing in computer vision. So transformers are totally changing everything about natural language processing. So GPT-3 is a transformer. That's the second fact. What's so cool about the transformers? And like, in short, transformers are just models that use attention. They have multiple attention layers, and they are, to be honest, even simpler than LSTMs. LSTMs were, like, at least for students, they're quite difficult to get. Initially, of course, even like a simple recurrent network takes time to comprehend, but LSTMs were like even more difficult. However, transformers are quite simpler, and because of how they work, they are very parallelizable. What this means is that we can train like transformers much faster, because like for recurrent neural networks, everything had to be done sequentially. There are some attempts to make it more parallelizable, but it was always tricky. So first things first, it's transformers now can get much more computing power out of. We can use GPU acceleration much more efficiently. The second thing is they can handle much longer texts. What this means, like even though like LSTMs had these like forget gates and remembering function, so they still couldn't handle like they're like, it always depends on the type of task, but in general, more than 100 tokens were like tricky for LSTMs. And for transformers, they cannot remember the whole book, but they can remember like much longer sequences. Or even, like, transformers are scaling so well that like maybe the book example is no longer valid. I have to rethink what I know based on evidence from GPT-3. So they can handle much longer sequences. The third thing is we can use the models for transfer learning. Recurrent neural networks, they're not really useful for transfer learning, as like in computer vision, we almost never start from scratch. unless we are solving very specific problems, not with images which we can see in real life. If you are using images of something that can be captured with your own like cell phone camera, you are most likely using ImageNet pre-trained weights with some popular architecture, not so with NLP. And that changed with Transformers. We are finally able to use transfer learning and using pre-trained models for pretty much, again, everything. Fact number 3 is GPT-3 uses a single model for all downstream tasks. So that's very interesting. Like previous models, BERT, I'm going to call it BERT because I don't want to say Bert, Albert, Roberta every single time. So BERT used for every single task in the like glue or super glue or whatever benchmarking framework, they had to add additional layers to the model, which they are specifically fine-tuned for this specific task. GPT-3, on the other hand, not so. They use the same model for everything. How do they do that? Is they actually have 3 parameters, like you can imagine it as 3 different inputs. So first of all, we give it a task description. Then we give it a few examples. By the way, this can be 0 shot, 1 shot, or few shot learning. So these examples can be skipped, but you can give 0, 1, or a few examples. And finally, a prompt, so your question. It does that. It's like actually really smart when you think about it, when you have a huge model. So you allow the model to actually learn what type of task it's actually you are actually asking it to do. So what that means is that we don't need to fine tune the model for each single downstream task. You can use the same GPT-3 for everything. That's really cool. What's few-shot learning? So I mentioned that the second thing is a few examples. So what GPT-3 shows us is that a language model which is trained on like a lot of data can solve NLP tasks that it actually never encountered. I mean, in the training data. And it's as I mentioned, it does a really great job even without fine tuning. In some tasks, it's actually better than fine-tuned state-of-the-art models. That's pretty amazing. So the model uses the few-shot learning. Like how does it help the model? Even though it's like 2 or 3 examples, it really it really helps the model to put things into perspective. By the way, this part, like I really try to understand from the paper how do the authors explain this part. So there are, and then try to find like alternative explanations on the internet. So my general picture is that there are like almost 2 schools of thought. Is the first one is that the model, that these examples help the model to understand what's expected. And the second school of thought is that the model, like these tasks, filter out the irrelevant, or like on the other point of view, they activate the relevant parts of the neural network, which are useful for this type of question. So, by the way, this one wasn't clear, and it's not. There's no answer to this question. How exactly? What's the mechanism behind the few-shot learning? And there are like at least a little bit of disagreement. I mean, it's very very detailed and minute thing, but still funny. So what the authors show us in this graph, it's actually straight from the paper, is that even giving these few examples, so you can see it's 10 to the power of 1. That's 10 examples. So even 10 examples are extremely useful. So if you have like 0-shot, even the largest GPT-3 model, the one which is called GPT-3, so even this model has a pretty terrible accuracy. One example gives it, like, bumps it from 10% to 40%, 45%, and adding a few more examples, 10 of examples, gives it an accuracy of like about over 60%. What's also very interesting is for the larger models, the impact, the upgrade is much more noticeable than for the models with like fewer parameters. So 1.3 billion parameters. If I'm not mistaken, that was the size of GPT-2, the all-powerful GPT-2, which was too dangerous to be released last year. Now it's like a joke. So, like, if you want to learn more about this example, like, I have the original paper in the links in the end. Now let's continue to the other graph, which shows that, like, more accentuates the difference between larger models and smaller models. So as you see, as the number of parameters increases, this divergence between 0-shot, few-shot, and 1-shot, it keeps increasing. So the right-hand side for the largest models, you can see it's like this few-shot really gives a lot of increase compared to, like, on the smaller side, the models are pretty much converged. Previously, we had so this was a chart about Turing NLG. So as you see, I remember, like, it was January, winter this year. Then Microsoft released Turing NLG, and everybody thought, wow, that's insane. A model with 17 billion parameters. It's like just really Microsoft wants to show off how their Azure platform, how much computing capability they are not able to sell. And they are training it, using it for training neural networks. So it was, like, really impressive, these 17 billion parameters. And right now we have GPT-3, which has, like, order of magnitude more parameters than the Turing NLG, which, as you see in this, like, last chart, had an order of magnitude more parameters than the other models. So then you like, even GPT-2, which had 1.5 billion parameters, and BERT has 34 million parameters only. So it's the trend is clear. The models are getting really bigger. By the way, what's really interesting, GPT-2 and GPT-3, pretty much exactly the same model. GPT-3 is just bigger. That's the main difference. Trained on more data, has more parameters. Talking about parameters, it has 175 billion parameters. It used about 3.13 to the power of 23 flops. And based on very conservative pricing, by the way, I read a couple of papers about pricing, so that was the lower bound. That's at least they would have used that much money to train the model. So training the model once costs $4.6 million. My prediction is in 2 years, these numbers will look cute. We'll have models which, like the same way as GPT-3, GPT-2 today looks cute. It was amazingly large, amazingly big just a year ago. Now it's, brings a smile to our faces. So I think that the same thing will happen with GPT-3. The next model is going to be even bigger, or bigger and more efficient. We have a few, we have a consideration from Andrew Karpati. He says that the transformer architecture of GPT shows the upper bound of memorization. It cannot think for a while. That's, by the way, Andrew has a great podcast episode with Lex Friedman, and he explains what this think for a while concept much more in depth there. This is a very fair criticism, and I personally happen to agree with Andrew, saying that we have to allow models to spend some time sometimes and get the results. If their task is easy, they can get the results fast. Pretty much, he's getting inspiration from how humans do this thing. Now let's talk about training data. So the model used, the total training data was 499 billion tokens. It was gathered pretty much what the data used looked like. They just downloaded the internet, close to they did a good internet crawl. They got lots of data. If you remember, just a few years ago, training on the whole Wikipedia was considered to be good. Now they also use Wikipedia, but I think it's the whole Wikipedia is 1% of the total training data. What's really interesting is that the model has 175 billion parameters, and they used 499 billion tokens. So the compression ratio, basically how much the model can memorize things, and how many parameters the model has, and how many parameters, how many tokens the model gets as input. So the ratio is actually better for GPT-2. It got 10 billion tokens as inputs and only 1.5 billion parameters. I mentioned that we pretty much used the whole internet. One thing which we fixed was leakage. So everything in the training data that had 13-gram overlap was removed. So if the test and training data had something which had 13 tokens in common, it was removed. So the fact number 4 is GPT-3 is biased, and I expect to see a lot of to date, Twitter is still raving about these amazing new things which people are doing. The people who got lucky and got access to GPT-3 API, they're raving about the cool things which we are building. But I imagine just in a month maybe, people will be criticizing GPT-3 for being biased. By the way, the authors had the fairness section. They noted that there were many various biases present in the data. They mainly analyzed gender, race, and religion bias. They confirmed that it exists, and they didn't do anything to correct the biases. That would be a lot of work, obviously, but the biases is still there. And the models, I expect that the model, it will soon start to show its ugly head. There, people will try to do something and then criticize GPT-3 for that. Because as I see right now, people are maybe bringing too much hype to this model in regards where they expect it to be smart. Let's talk about the performance of the model. How smart is it? So one really impressive thing, for me especially, is that it's almost a human level in ability to generate short, so about 200-word articles. It's also state-of-the-art in some translation tasks. So you might be like a little bit underwhelmed here. So GPT-3 is so much bigger, and it is state-of-the-art in only some of the tasks. But I'd like to remind you that in general, state-of-the-art is achieved by specialized models, so the models which we are fine-tuned for this specific task only. GPT-3, especially for tasks related to translating something to English language, it is state-of-the-art as is. That means like no fine-tuning. So general, that the same. Remember, I said that we use the same model, the same GPT-3 model for everything. So they don't have to pre-train it. They don't have to fine-tune it in any way to be state-of-the-art in these types of translation tasks. So that's really impressive. And of course, the model has generation in the name, so obviously it's going to be good at generating text. So what does almost a human level mean? So it means that the model, and you see that there is not a single GPT-3 model. We have a bunch of GPT-3 models, and the last one, the bottom one, the 175 billion parameters, it is like what the authors call GPT-3. So it's the largest one, and they say that's the GPT-3. So what's really amazing here is they asked participants to distinguish between texts like 200 word news articles generated by humans and generated by the model, and only 52%. So if the both models, if the model would be perfect like human level, the best what we can hope for is 50%. I mean, human level model would have 50% accuracy. GPT-3, the largest GPT-3, has 52% accuracy. So that's really amazing. That shows that the model is, like, for all intents and purposes, in this task, the human level. And like in the original paper, they expand on it. It's really interesting. They even show the best performing article which GPT-3 wrote, and they show the worst performing article. So to be clear, the worst performing article was pretty like underwhelming. It was really easy to distinguish that it's not generated by a human. Lots of factually incorrect information. The best one was at the same time pretty impressive. It looked very interesting and very convincing that a human wrote it. So you can compare how, like, increasing the model size, like, and I love, by the way, this chart. The main thing which it like for me, what it means is like it clearly shows that smaller models, so even GPT-3 small, has like barely better than control. So control is deliberately bad model. GPT-3 small is pretty bad, and just by increasing the number of parameters, it gets better and better and better and better. And at the end of the day, it gets close to being human level. So pretty much what this thing proves to me is we can go further. We can go and have a trillion parameter model, and it might be smarter, or like for this task, it might be better than humans. And yeah, maybe that would be pretty difficult because it's not trained on something that's better than humans, but it will be human level most likely. Some of the cool things that GPT-3, like, and this is the one of the people who got access to the API, is they create lots of these amazing articles, or come up with these amazing use cases, show us articles, or show us video captures of these things. So that's one of the examples. What cool example of what GPT-3 can do. It can like the person feels that it's like seeing the future. It can do so many things for them. They tried it on the API which we got. So fact number 5 about GPT-3, it can do some reasoning. And by the way, this is quite controversial. Again, it's really unclear if it can really do some reasoning, but there is some evidence that it can. In the original paper, what the authors investigated is how good the model is at just plainly adding numbers. So if they add 2-number addition, by the way, is 100% accurate. 3-number addition is also very good. Subtraction is a little bit worse all the time, but the model is pretty decent. But like going to 4 and 5 digits, it gets worse. So what does it mean? The model, by the way, they carefully checked that it's not just memorization. My initial idea was, oh, so they just encountered in the training text these numbers. So by the way, this is not memorization. They ask the model to give a prediction about like adding 2 numbers, which it hasn't seen before, and sometimes it got much better. By the way, not sometimes, but always it got much better prediction than a random model would. So if you have to add 2 3-digit numbers, so we have like a very large, pretty much a 1 in 1,000 chance. So 0.1% accuracy would be expected, and you see the model is doing much better than that. So it's actually learning, it has some capability of understanding what numbers are, and it starts to learn some arithmetic. So that's quite interesting for me. I'm not, by the way, in any way claiming that it can do reasoning, like proper reasoning, but it can do, like it learned this really interesting thing. And I encourage to make your own opinion. The paper itself is really long, but you can go and check this specific section in the paper about how it learned arithmetic. Arithmetic, by the way, wasn't the only thing that it learned. There are cool other things. One thing which I really liked is like conversion or translation between standard English and legal English. And the smart person says that he won't need lawyers anymore because he gave these. And by the way, this is the few-shot example. So he gave the model these few examples, and then he asked the model this question, and it translated pretty okay in my mind from standard English to legal English. That's really interesting. Fact number 5, it can write decent comedy. I understand, like, and I want to directly quote Eliezer Yudkowsky's one of my like heroes, one of the people whom I really admire, and he I saw it on his Twitter feed that he was linking to this comedy. I have it. It's a comedy about Reddit Ask Me Anything, and people considering, I don't remember exactly whom it was, but from one, like a few of the popular tech like influencers, or I guess not tech influencers, but tech people working in tech. They're considering, I think it was Google Larry Page, or yeah, I don't remember exactly who it was, but even though he says that even though it was selected. It wasn't, like randomly the first thing or just a random pick out of 100 comedy routines which GPT-3 wrote. It was still like surprisingly good. And I personally, it was funny for me. I actually laughed. It was a nice reading. So I have it. I have the original link in the like resources coming up later. You can check it when I post the presentation online. So what's really interesting. Uh, it's talking about comedy does other things too. So if at some point you're unsure if you can pass a phone interview, GPT-3 can help you. And I give you like a minute to read through all of that, but it is surprisingly like, I mean, I can imagine this passing a Turing test if the interviewer would be using just a chat program to do phone interviews. Of course, like phone interviews and using chat for that doesn't make sense, but still, the model is performing really good. It remembers a lot of stuff. It asks reasonable questions, and especially the part in the end where the model says, "Okay, what am I missing?" and then fixes the stuff the, where the human gives it an input and you're using the variable x without defining it, and then the AI defines the thing. So if you're doubtful about your chances passing phone interviews, you can always get help from GPT-3. It's not great at coding yet. Couldn't get a job, but maybe that will help you out with some questions. We have quite a few of examples, really interesting examples, all of these. I just don't want to, like, I'm going to leave them right here, like my hand selected examples. All of them are really cool, but I won't be showing them you them today. Please check them out yourself. You're running out of time. I just wanted to bring your attention that these, for me, they're the most impressive ones. And these are the resources. So, of course, the original paper, like 2-minute paper overview, and a few other, like the last one is the comedy one, and the other one is a longer technical overview. So now it's time for Q&A. Please use you see a link, slides app, Google. So please use this. Don't ask questions on YouTube. Ask questions here, and I'll try to answer the questions which you have. So I'll give you a few minutes to come up with your questions. I see we have one question in YouTube comments. So while you're writing your questions on Google, so the question in the comments is, how do I get my hands on this model? So as far as I know, you have to ask OpenAI to get it. Most likely you won't, but you could try. It is like provided to only a handful of people who are testing it, and they don't even have access to the model itself. They have access to the API of the model. So I actually have one more thing which I would like to show you. So please continue adding your questions. And I actually have this bonus round. So while I was making this presentation, I was doing my research, and I noticed this very, I guess, troubling pattern. So people need some type of images for their GPT-3 articles. So this is going to be my like list of most terrible images next to GPT-3 articles. And I was wondering myself, so what should you put? Like if you create an article, what type of image should you put next to the article? And it seems that, like for me, the most reasonable thing is to add the name and the authors, but digital, like in quotes, brain or just a robot seems to be winning much more. So we had this pretty machine as like next to the article, which is enabling some switches. That's very AI. Like yes, if you see this humanoid robot-y shape, it's of course it means that it has a lot of AI going on. That's one is really creepy. It's GPT-3 AI and the future of books. So this creepy like metal-y thingy reading a book. This one is really cute, like robot and thumbs up, of course, GPT-3. And like this one, I can't say creepy nor cute, right in the middle, just on the face saying GPT-3 trying to prove that robots can write. And at the end, this cute fellow making reading a book. So my point of view, please don't add robots to your GPT-3 articles. Just stick with something else. Like I guess literally anything is better. People keep like trying to make these models more human than we are, and then they are surprised when they don't behave like humans or human minds. So please don't encourage them to like use this incorrect human personification and try to reverse the trend. That's of course possible. So back to Q&A, we have one question. It says that's what is the definition of a parameter for someone not familiar with this concept. Yeah, so a parameter is a variable. So imagine if you have like maybe you are familiar with logistic regression, like that, or even like linear regression. So we have a few parameters usually, or even just one parameter. So that's like what weight. It's parameters sometimes are called weights. What in what's your multiplier for your x? If you have a model like the very simplest model which I can think of, which you all should encounter at school, is y equals ax. So a is a parameter, or y equals a1 x1 plus a2 x2. So a1 and a2 would be weights or would be parameters. GPT-3 happens to have 175 billion of these parameters. So of course, when you learn about neural networks, it will make much more sense. It's like, or I guess when you start learning about linear logistic regressions, that will start to make sense. Neural networks make more sense, and finally, transformer architectures will make the full sense. Donatas has a question: is GPT-3 word-based or character-based? For example, if a new word is introduced, that will not, in the training data, can the model use it? Good question. If I'm like about 80% certain I think it uses some type of subword tokens. I don't remember. It might be as I'm saying. I'm not very certain, but I think it uses subword tokenization mechanism. So not a character, not fully a word, something in between. Right. So that's it for today. I hope that this was interesting. I hope that you know more about GPT-3. Please go ahead, check the resources, also check the most interesting examples. They are really cool. I like, at least for me, they were really cool. And see you during our next meetup in a month. Take care. Bye bye.